Welcome back, chemistry fans. Today, what we are going to do is our Unit 6 exam solutions. There's only 4 questions. This shouldn't take us that long. Gonna need your calculator. Let's jump right into it. Share the screen here. And well, these are questions 3 and 4. So let's go over to 1 and 2. And what we're going to do, hopefully, is find questions 1 and 2. There we go. And then we can start in on them. Okay, so stoichiometry. You've got 2 starting materials. So this covers pretty much all versions of this. I've got 600 grams of this starting material, but I only have 53 liters of this. So I've got 2 different units that we're wanting to make conversions on. It does not matter which of the products you choose to convert to, and it doesn't matter what the unit is that you convert to, as long as you're consistent that both of the materials go to the same product, so we have something to compare to and they're in the same unit, then we're okay to do this. So I have 600 over 3 times the weight of this compound. Well, mercury, it's given to us 201. The oxygens, there's 2 of those, that's 32, and there's 2 of the hydrogens, that's 2 total, equals X over 6. Now, I could do 6 times 18. I could do 6 times 22.4. I could do just 6, and it will be able to figure this out based on number of moles. Okay, so that's what I'm going to do, the simplest path, fewer mistakes possible. So I'm going to do 600 times 6 divided by 3, divided by the total of 201 plus 32 plus 2, that equals 34, 35, 235 is the mass right there. And I get 5.11 moles of water. Now let's do it for the liters that we have as the other material. So I've got 53. Change my pen color. So I got 53 liters over 22.4 liters equals X over 6 again. So I got 53 times 6 divided by 2 divided by 22.4, and I get 7.098. So that's going to be 10 moles. Okay. So what we can hopefully see here is that this up here is going to be my limiting reactant, meaning that this material is going to be in my excess. So what we need to do is take that 5.11, and I will do that now up here. So I'm going to take that 5.11, I'm going to divide it by 6 again, and this time I'm going to convert it to the unknown amount of the excess, the 53 liters, but we don't know how much of that 53 liters we used. So that's what we're trying to figure out. So I will do the math here, 5.11 times 2 times 22.4 divided by 6, and I get 38.2 that is used. How much is in excess is where we take the 53 and we subtract it from that, because this is how much we started with, and if we subtract the 38, that would tell us how much is actually in excess. 14.8 liters in excess. Okay, so if you can handle that, you can handle any stoichiometry that I give to you. Now, number 2, we're looking for a percent yield. In this problem, we start with 8.3 times 10 to the third. Well, the first thing you're going to have to know how to do is to convert this into a regular number, 1, 2, 3. That's 8,300 of the reactant of acid. So some of you may be saying, well, which is the acid? Well, if you kept reading, it would say that there was sufficient amount of this, meaning we're not going to use this. So this is my starting amount, and we are interested in the product acid. I know these are acids both because they have H in the beginning. So we're going to take our 8,300, and these are in moles. So I'm only going to use the coefficient 12. On the right side, the amount that you use, the amount that is produced, it's got to be in grams because we need to compare it to grams. So 4 times the weight of that acid. Well, the acid has 3 hydrogens. It has 1 phosphorus and it has 4 oxygen. So if I add 64 plus 31 plus 3, I get 98 is that weight right there. So now I'm going to cross multiply and solve, and this would be how much was theoretically produced. So I got 8,300 times 4 times 98 divided by 12. And I get a big number, 271,133 is the theoretical. That's not how much was actually produced. It says the actual amount produced is 255,000. Divide that by what we theoretically produced, and we would get our percentage. So 25,500 divided by that answer gives me roughly times 100%, 94.05. But since we are in sig figs, 94.1%. Okay. Here we go now into question 3 and 4, where they are a little bit more theoretical in nature, or a little bit more flexible. It's just, do you know why we're doing stoichiometry? Yes, you've learned a process. Why the heck are we doing it? If I see one word in there, you want to be able to predict. I know that you're on the right track. Basically, though, you want to be able to predict reactions. Amounts in reactions. Predict amounts in reactions. If you can see that word predict somewhere in there, that's what we want to be able to do. We want to be able to control a reaction. If you can put that in what, 2 or 3 words, then I'm going to give you full credit. If it takes you 50 words to do it, that's fine. If you do it in more than 50 words, you didn't know what you were doing. You've got to be able to truncate and concisely explain this. I do not want a word salad of just continuous nonsense. Just tell me, why is it important to a chemist? Why is this tool necessary for them to be able to predict products, for them to be able to control manufacturing, any of this? Just tell me about it. Number 4, what is the mole ratio? Well, the mole ratio is the number of coefficients in comparison from a balanced reaction. In other words, if I've got one of these balanced reactions, let's say I've got methane plus oxygen makes carbon dioxide and water. So I've got 2 here and I got 2 here. My mole ratio could be any of these coefficients. It could be written as this. It could be written as a fraction. What it is a comparison. Comparison of the number of coefficients in a balanced reaction. Comparison of coefficients in a balanced reaction. If you've got that, or some comparison coefficient needs to be stated, it needs to be from a balanced reaction. A few keywords that I'm looking for, but it didn't take 50 words to tell me what you should know about a mole ratio. And how is it used? It's used in stoichiometry. It's used to convert moles of reactant to moles of product. Moles reactant to moles product. All right. This is everything that I need to see from you. Hopefully it's a little more clear, or if you did not score 100. This is a very great opportunity for every one of you to score 100. Thank you so much for your time. I will talk with you again soon. Bye-bye.